Okay, so hello and welcome back to another Unity tutorial. In this one, I'm going to be going over shaders again, and this is going to be kind of like a part 2, the last one obviously being part 1, and that was covering well, how to set up a shader, how to install it, and how to make a simple shader with the Fresnel effect. And at that time, I didn't really know much more about shaders than that. I just wanted to make an introductory tutorial to how it works. And since then, as well as working on Python and JavaScript and all the other stuff, I've been looking into shaders and lots of functionality and how to make like animated shaders and what all the different things do in the shader graph editor. It is quite complicated stuff. It's obviously nowhere near as complicated as hard coding it yourself, but there's a reason they made this feature for people like you and me who don't know how to code shaders. But anyway, before I get into that, I just want to mention that I've made a Discord channel over here, and let me just drag it on my screen. So basically, I'll put the link in the description. I've just made this channel like an hour or two ago, whatever, and it's for anyone who's interested in coding for, well, anything I do in my channel. It's kind of like my YouTube channel's Discord. I'll put the download link, well, not the download link, sorry, just the link in the description to like all my videos now. So you can join here, you can come and have discussions in any of these channels. Obviously, it's pretty empty now. There's only like 4 of us because I literally made it a few hours ago, and I haven't yet advertised it on my channel. But I hope that more and more people will join this, and then we can have discussions about everything. We've got stuff where we can put resources for like free assets and stuff. We've got like showcase that is only accessible to me and the other admins for like showcasing if you've made anything, rather than spamming it in one of the channels and just being a nuisance. I can put it in the showcase where everyone gets to see it, and they'll get notifications for it in the showcase channel. And obviously I've got it for all these other things like C++, Python, web languages stuff, and there are voice channels. I've only just made the server, so if you've got any suggestions, just ask and I will make the changes. But for now, it's only small enough not to bother with. But anyway, let's get into the video. On Unity's website, when the shader graph came out, they made this picture, and they showed how they've got this one model, and they've made different shaders for different things. So you've got like default, the glow. I think that's to do with underwater because it looks like it's water if you go close. Obviously the temperature, like heat one, whatever that's meant to be for cutting out. Snow, where it's like it only renders it on the top looking down. I'll do that in a different video, and so on. And they have made these available so that you can go in and see the shaders and how they made these. And that's a good thing because normally you might see a shader and just look at it and wonder, well, how does it work? Well, obviously with shader graph you can just open it up and quite visually see how it works. But I'm going to make a tutorial on how or why everything that's used is used, and how to link it all up and what it all does, and show that if you missed it out what would happen and so on. Because this is about not just copy and pasting shaders, it's about learning how they work. So we're going to be making this hologram one here, and I'll show you all the different parts of making it, the different the stages of making it, and what the outcome looks like, and so on. So without any further ado, we will get into it. So the only thing I've got prepared for this, you have to obviously set up it in the lightweight render pipeline with shader graph, which you should know how to do from last video if you don't already. I have just gone into that package and I've grabbed the hologram lines, which is what they used as the texture for the effect. You could easily make this yourself probably if you wanted to. I'll just open it up in Paint here. You can see it's literally just gradient lines, so it's like black going grey going white, black going, and that's it. That's all you need. I think I didn't close it. Anyway, so what do we need for this? We want a shape to have the effect on. So here's our capsule. We want a material to put the shader on. So material capsule. That's lightweight, and then we want a default shader for the PBR thing. So shader PBR graph capsule shader, and let's apply that. So here we go, and we open up the shader graph. Boom, here it is. So if you remember from last time, this is kind of like the default panel. Like so when you go on your material normally, when we go onto here, if we had like a standard shader, you see you've got all these different like albedo, normal, metallic, all that lot. But because we're using the lightweight render pipeline, it wasn't physically based, we're doing our own, it's on graphs. Oh yeah, I'm in this other package. Where's all this capsule shader? There we go, this is the one we're making. So the first thing, well, you can do, the thing with shaders is there's not a defined order you have to do everything. I'm just going to make it in what order makes sense. So let's just move to the side. So we want to use our texture, so we need to have it as an input. So we're going to go in here, texture, and we'll call it, it's going to be the hologram, so hologram texture, and we will select the hologram texture. See, I'm using the project that was supplied to build it in, because for some reason in my version of Unity, this panel here, the inputs panel, just isn't there, and I've looked at what the problem is, and all the people complaining about it have had it recently. There is a workaround where you have to delete certain files, and I'm just not messing around with that. Supposedly a fix is meant to be coming in the next few days, so I hope that is the case. But for now I'm doing it in here. It doesn't matter, it'll be the same for you. So here we go, we've got the texture. Now let's drag that in, and what do we want to link that up to? Well, we could just link it up to the albedo, for example. No, we can't, because that's just the texture on its own. We have to link up the texture to a sample texture 2D, which is what takes in the input texture, and you know, you can see when I put it in here what it looks like. So this is like the preview window, and the texture is going to be input to the texture part here. Now we can output that to albedo, for example, and as you see, our material looks like this, which is not what we want, but hey, it's somewhere to start off. Now we haven't actually applied our shader yet, have we? There we go. Here's our very odd looking thing. Now that is the same as literally just applying the texture straight to the object, but that's just how it's going to start off. So we obviously don't want that on there. Get that away. We need to make space probably. So this is great and all. We've got our texture, but what we want for this is we want it to be animated. We want the lines to be moving, and for that we need to have animation. And when it comes to shaders, and it's not really animation, it's generally offsetting by moving the texture around to make it look like it's animated. So the way you can move stuff around live is by using a time module, and there's different options. There's time, sine time, cosine, delta, smooth. Now I know what the top three do because I've done maths. Time is quite literally just it's incrementing all the time, so it keeps going. So when we offset this, it'll be constantly moving up, 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 or down, down, down. Actually, depends what the value is. But then sine time, well, I can actually show you what it does. But if you think from maths, I will get up a picture if you don't know what it looks like. But sine graph. Oops, I misspelled that. So you see here, sine graph. This is literally how the output works, because it's going to be outputting a number. Time will be going 0, 1, 2, 3, 4, 5, whereas this will be going 0, 1, 0, minus 1, 0, 1, 0, minus 1, so on. And then the other one was a cosine graph, so cosine graph. It looks similar, it's actually different, it starts on different values and pulsates differently, but we're just going to be using time because we want it to go linearly. You'll see why. Now we're going to be putting this into a multiply, and the reason being is that this time is well, let's put it in. So we're going to be multiplying time, which is going to be just a number incrementing, and we kind of need another value to multiply it by, which is going to be the control speed, because this value here is a default speed. We can't change this, we can't change what time is. We have to multiply it by a value to either slow it down or speed it up. So we're going to add a new vector1, which is going to be, let's put like scrolling speed. We'll have that down here, and that'll go into here. So that now when we go into our properties, into our parameters, we can change the speed at which it scrolls, and you'll see how that looks when we get to it. Now, what do we want? With this value that's going to be increasing at a constant rate when we keep that still, we need it to be moving the texture. Like this file just still like this obviously doesn't look great. So the way we can do that is we can create an offset, which I think is called a tiling and offset. Yeah. Okay. So here it is, and let's move everything. So what do we want to do? What do we want to hook up where? Well, the output of this multiply is a number, and that's going to be the offset of the thing. Now, this takes in an x and a y, so actually, let me just, can we change it? No, I have to remake it. Remake the scrolling speed vector as a vector 2, because it takes in, where these little numbers in brackets are, the parameters, it'll tell you whether it needs a vector 1, vector 2, t for texture. It lets you know what it wants to take in, and I wasn't reading, so scrolling speed. Now, this value might be, well, whatever, I'll set it to 1 for now, and I'll see whether it's too much or too little later. Now let's get rid of this down here and hook that there. Okay, now this looks a bit odd now with the yellow. Just ignore that. The yellow doesn't mean it's going to go yellow. Okay, now there's two other inputs. So there's a tiling and a UV. Now we're going to leave the UV for now, and I'll come back and do that later and show you why that's a good idea, because otherwise it might look a bit silly, and it will look a bit silly. So what we need for the tiling is, when you have a material in Unity, for example, if you put it onto an object and you have a tiling of 1, 1, it means that the image width will be 100% and height will be 100%. So your image will be fully covering it and it'll be stretched. Tiling means that you can have the image multiple times spread out along the image. Now, I hope you know what this means. If this is hard to explain to someone who doesn't know. If you do know, you'll understand what I mean with tiling, because it's the same when you're setting up a normal material with a texture. Now, the reason why I want tiling on this is that this is a kind of like a infinite image, like in the sense that you could copy, paste it, and place it above it, and it would be continuously looping. It's on all sides. So if I put that to the side, there, you could build up a bigger image of this by smaller ones, and it would look seamless. The reason why I want an offset is so that we can choose how wide the gaps are between the lines. So that's just all for tweaking purposes. So we need a new vector 2 called tiling spacing, whatever. And we're going to hook that into tiling. And we can just default that at 1, 1 for now. But later on, that's a bit annoying with the shader graph. When you put in scroll over and type in 1, it sometimes goes to 10. Maybe it's just new bugs, or maybe I'm being silly. Now that still doesn't look like anything's happening, but if we output it to the UV, as you can see, it's very, very quickly scrolling. Now if we save that, it appears to be too much for some reason. Oh no, I'm just not outputting it to the albedo. Now if we save it, that is a very, it's not a very nice shader to look at, is it? It's a bit too fast. So let's turn down the scrolling speed in here to like 0.3. That still looks a bit too fast. 0.1. 0.1. Don't know why it gives all these weird values, but anyway. See, that looks a bit nicer now. Okay, because we first of all gave it a default value, then changed it in here, it's not changed it in the actual scene. So let's go to our material and change the scrolling speed to 0.1. So as you can see in here, you can tweak the scrolling speed on the X and Y. Now, when I think about it, really, changing the X won't make a difference at all because it doesn't move on the X. Well, actually, if you set it really high, you can actually see that split line. So I guess it is nice to keep it low. But even if you set it to 0, I think it would work. Yeah, it might as well set it to 0 because it's never going to spin. Okay. Might as well set it to 0 in here for the X. Ooh, that looks odd now. Doesn't make a difference anyway. So you could kind of say we're nearly there, but this isn't really a hologram because it's very it's not, the alpha is full and it just looks wrong. So what we want to do now is we want to do something with the texture. Now, rather than sending the output of here, let's just get rid of this. rather than sending that to the albedo, which is just the flat texture of the thing, we want to actually send it to the alpha, so that the dark parts on here are where the alpha's higher, and the light parts are where the alpha's lower. Now, you can either send in the red, green, blue, or the RGBA, but it'll have slightly different look per thing. And the reason why nothing is happening is because we still haven't got an albedo, it's just a flat colour. So, what we need to do now is we need to output the RGB, but not straight into the end, because if we do, then it's just going to look how it did just earlier. It's just going to look like that, which we don't want. So, we want to invert it, because you'll see, well, let's not invert it just yet. Let's just, well, no, we've tried not inverting it, so let's try with inverting it. So what 1 minus does is, it takes the value out of here, and it takes 1 minus that value, which inverts it. So 0.3 will go to 0.7, 0.4 will go to 0.6, and so on. So it's just like maths. If well, this has to be, every output for this will be between 0 and 1, and it'll give you the reverse. So as you can see, that is just a reverse of that. The dark bits are light, the light bits are dark. And because this is generally dark, this will be pretty much generally light, because we've inversed it. Now we can output this to the albedo. It won't look just right. It'll look better though. As you see, it's just kind of white now, which it hasn't solved much. But to make it look better, we can also output it to the emission. And that's nice and all, but since we're just using white, actually no, the reason why it's not looking right is because these values are already set. I was meant to get rid of these. We can't see it when it has the smoothness of that. Now we just need to change the color, because on our 1 minus, we're just outputting that straight here. So we need to get another multiply, and we want to give it a tint color. So let's take in a color. So let's call it tint. We'll set it equal to let's go for a purpley pink tint. Why not? And we'll put that into the alpha, and we will go from the 1 minus output. Let's get rid of this and get rid of this. Let's output that into here. So now we've got our like pinky color, and set that to the emission as well. Now what's the last thing we have to do? The transparency. There's some problem with the transparency, and that's because I've got it on opaque, not transparent, so the alpha doesn't matter. Here we go. There's also other tweaking we can do, but as you can see here, we've now got the hologram, and it doesn't look perfect because there's other tweaking we can still do. I don't like the spacing on the tiles. Well, let's just go down here. There we go, that looks much better. Well, it does look better on the sphere. How does it look on the capsule? Tile spacing x2. Y1, that's right, that's set. All we really need to do now is we can tweak with these things down here. So we can change this, what does specular look like? I think specular is right for this. Oops, sorry. How does that look? It's looking a bit better. What else could we do to it? Oh yeah, one thing we can do is, as you can see now, if I go away and come forwards, it looks the same. Now, if this model had like other parts coming off it, if it had like, if it was a human, like you see in the, I don't have the image up anymore, but the problem is with the model of, well, let's see quickly, sorry, can we just change the thing to the guy? Here we go. Alright, just imagine this is what we were working with. It looks a bit stupid, because all the different parts just don't line up. Like everything, so the leg has its own bit going down, the foot has its bit going down. It's technically, it's working, this is how it should be working, because there's one thing we're missing, which is on the tiling and offset, we're just leaving it default. We want it to take in the input of where it is in the world, or well, where it is in comparison to the camera. and the camera we have to use screen position. So if we simply output that to UV, now save it, and the hologram looks right, and as we go further away it's like just one line, but as we get closer it'll be more and more and more and more and more. But as you see, it doesn't matter how we look at it from, it's always got the exact same, like it looks the exact same. Now I'm going to close it. I'm going to show you it first what it looks like so that you can see for yourself. Now this is basically the same that it comes with in the like package, but I've explained what everything is, and I'm going to quickly go for everything. So first of all, sign time, just showing you how that would work. Since that is a number which goes up, down, rather than just up, 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 it would look like this. See, it goes down, up, down, up, which you might want for some shaders. You will want that for some shaders. It looks pretty cool for some kind of like well, anything in a shader like that you want to move forwards and backwards rather than time, which will just move forwards. Then scrolling speed is literally just the speed at which this animation goes. Screen position is relative to where we are, where our screen is. So if we get further away from the thing, the UV will change. If we get closer, it'll change. Tiling is just the spacing on the, well, as you can see on here, if we increase the thing to 10, then there's basically no gaps in between. We've changed it, oh, it's 102. Change it to 1, then we go like 0.5, 0.4, 2, 1. It doesn't appear to even go any lower than that. It doesn't want to go any lower than that. But increasing it makes a difference. Doesn't? Wait. It just seems to have stopped changing now. There we go. But anyway, we'll leave it at 2. 2 worked well. Here's the actual texture which we're multiplying by. So if you wanted this effect for a different texture, just replace this, which is here, with a different texture. This is the main hub for it, where it we take the texture and move it, and then we output R, which is red. Now we can output GB, doesn't matter for the alpha. It basically just means we take, because RGB for the black and white image will be the exact same basically. Like if I take this off and I put in G, it's going to be the exact same. I'm assuming use R because it's there, and that just means that the transparency of the image will be relative to this, so that if the black bits will be visible and the white bits won't be. That's why here when it goes black, and if you go follow it upwards, it goes light. On here it goes from like nothingness, so like low transparency, up to high transparency, because generally encoding with color, like white is 1 and black is 0, because black is the absence of light and 0 is 0, nothing. And then up here, this is for inverting the color. So I showed you what it looks like without it inverted. So it'd just be all this reverse basically. This tint is just like where you can input your own color to give the, tint for the visual. You can just go in now and change that here and just see what it looks like. You generally want to keep it full transparency though, because the transparency is controlled elsewhere. Obviously you can have a cool colored hologram shader for whatever you want. And the reason we put it into the albedo and the emission is because if we just had the albedo, it's missing too much, because as you get lower down, the alpha goes down. And if we had it just on the emission, it actually looks alright with just the emission, to be honest. But just having an emission, obviously an emission is the image is emitting that. If you've ever made like, I don't know, a material that emits light, that's generally how you do it. That doesn't mean that it's a light source. That's not the same thing. You could see very subtle differences in this scene if I changed it, but you will notice it at other points. But anyway, I've covered everything there is in here. Obviously 1 minus, as I said, you take a value, 1 minus that value is the inverse of it, because all these values go from 1 to 0, 1 being completely white and 0 being completely black, and everything in between. Anyway, I hope this video helped. I hope you liked the tutorial. I will do more shader videos on the other shaders that they show for Unity, for Shader Graph. I'll go step by step on what all the parts do, how to set it up, why you put this there, and then obviously you can go away and make your own shaders for whatever you want. Because the goal of learning how to make shaders is so you can make your own custom shaders, so that everything you can make like stylized graphics, or you can make cool effects like this, which would be a pain to do with animation. It's not really possible with animation. You could do it with texture sheet animation, but it would be painful, definitely. So it's a lot better to learn how to make shaders because it's so useful. I'm still learning, so don't be too harsh on me. I'm not spreading any misinformation here. I'm still learning I'm learning everything that's in the tutorial I'm going to make. Like, I understand all of this, so I'm making a tutorial on this, and then when I understand more on something else, I'll do it on that. But I'm interested in learning it too, so that's why I want to make these videos, as well as helping others. If you want more of these videos, just ask in the comments below. Like, subscribe, join my Discord. Everything you can to get involved would help a lot. But anyway, yeah, this video is dragging on a bit, so if you like this video, well, I've already been through the outro, so thanks for watching, and goodbye.